and I think I'm going to start using the back burner in my when cooking from this on. So let's have all the three speakers up front there. And we have about 15 minutes for questions on this session.
You can go 20.
Or 20.
We'll see how it goes.
Depending. We could have 20 minutes, okay. So I thought that I would ask the same question that was earlier asked for the speakers when thinking about what is your insights on if each of you could address what are the key open questions when we think about mitigation of exposures.
Bill Fisk, I touched on them. I think for mitigation, for the particles that are allergens or inflammatory in nature, what are the appropriate techniques to deal with those and help reduce the related respiratory asthma health effects? I think we really need a better understanding of that. Also, we have large predicted reductions in morbidity and mortality when we use filtration to reduce indoor particle levels, but those are predicted, and I'd really like to see some empirical data to support those more than we have today. It's a challenging study, but I think it can be done, that kind of work.
Let me add to it. I think that one of the biggest challenges in terms of mitigating exposure to particles as well as gas phase is a variety of different methods which are now being deployed. I mean, the filtration has been used, probably it was the most widely used method, which is true for 20 years ago. I'm not sure it's still true today. I mean, mechanical filtration. So with the variety of methods available and the fact that some of these methods, although being efficient, they produce various byproducts. I think the challenge, the big research challenge is really to identify these byproducts, to identify the optimal condition, if at all possible, when the method is efficient in reducing the exposure, at the same time it doesn't do any harm. So in given the variety of this method, the booming market for air purifiers in this country and in Europe today, and the same is coming to China, I think it's a very important challenge that can be addressed through research.
Okay, Brett, do you have comments?
I guess I'm really looking forward to tomorrow morning because I think that while there's still lots that we don't know, one of the big questions for me is how we can better communicate what we do know already. And I'd love to see more studies that investigate that. What messages resonate? How to more clearly communicate information in a way that sort of common people can use it. And those common people include the building professionals who are going in and making some of these changes to the building, and just homeowners, building operators, etc.
Okay, thanks. Now we open the floor for questions in the room. Glenn?
Sergey, just a quick question. Do you know what the mechanism is by which the cold plasma inactivates the viruses? And if you do have an idea with that, do you think that would extend to the other microorganisms?
I really don't feel comfortable in characterizing the mechanism. So what I know, and it's very limited, that the reactive product reacts with viruses. That in a similar way, the viruses release protein. The similar way that it happened with the thermal exposure. But I really don't have any idea mechanistically, and I believe that this, what I said now, is rather simplification of what is going on really as compared to thermal exposure.
Right. Question for Sergey on the thermal inactivation. Does that produce any fragments or byproducts, like ultrafine particles of ultrafine size that used to be bacteria and spores?
It's a very good question. When we're talking about thermal exposure at high temperatures, I characterize the high temperatures like, say, 300, 350, 400 degrees centigrade. The inactivation is very, very high. At the same time, it's not a mechanical disintegration, which comes actually at the level of 600, 700 degrees, and then you can perfectly achieve 100% inactivation. That's about a fragmentation. So here you definitely see pieces because you mechanically disintegrate a spore or vegetative cells. You do see it much lower temperature with viruses because the protein was detected by this group in Vienna. Now, I do not know whether we can see the same thing at relatively moderate level of inactivation, let's say at 100 or 150, 200 degrees centigrade. And the reason for that, we tried to get to measure the particle size distribution in our research, but the effect was masked by the gaseous components coming at the same time. So we could not really differentiate the particle size distributions, and this would otherwise prompt us whether we do have a fragmentation effect that you are asking, I understand about, or we didn't.
Okay, there on the left-hand side.
Jill Bracey, I have a question for Bill. So I'm wondering about, especially thinking of low-income homes, the difficulty or expense of retrofitting. If ASHRAE 622 only requires a MERV 7, the difficulty in retrofitting an HVAC system to take the deeper MERV 13, MERV 16 filters.
Others probably have comments on this too, but we are getting filters that can fit in standard filter slots that are higher efficiency, maybe not the highest efficiency today, that are just more highly plated. Also, there are systems that can be, say, installed over the return grill instead of in the furnace system that aren't that hard to retrofit. So I think I think in many cases you don't need a retrofit, and the retrofits are not that challenging. That said, in a really low income environment, you know, the homeowner or the renter is not likely to have the resources to do that. It's not their highest priority.
So I'll say a word about that. There is this issue of pressure drop is sometimes overblown, but in many cases a very real issue. So there are lots of systems that are installed that are already overly constrained on the return side, meaning that essentially there's not a big enough duct, there's not a big enough filter, so that they're already, I think, they're kind of working a little harder than they should. So in those systems, increasing the pressure drop of your filter, which may be fine in a well-designed or well-installed system, could be problematic. And then especially if you're not going to change your filter regularly, so then as the filter loads, the pressure drop will build up. So I think there's a legitimate concern about what you do in a retrofit situation where you're just putting a better filter into an existing system, and some caution should be applied there.
So I have a quick comment that's not a question that I hopefully ties together several of the sessions today. But starting with Brett's discussion about venting of exhaust from stoves. In the great nation of Texas, we sometimes get confused between the attic and the outdoor environment. So there's a lot of ducting from stove hoods that vent into the attic. And that causes great soiling with cooking oils of the top of the attic and the insulation in the attic. So here we have venting from cooking activities with unseen spaces and a whole bunch of unsaturated fatty acids coating surfaces in the attic, which makes the attic extremely reactive. And so, you know, all these things sort of tie together, but it's an example of how one activity and one small change in a retrofit can lead to lots of chemistry in a place we don't think about chemistry going on.
We've seen that in New Jersey too.
Okay, so I guess it's all over.
Terry Brennan, Cam Road and Associates. Brett, I was interested in the slides that showed big reductions in the entrance of the transport of outdoor air PM by air tightening the enclosure, which would tend to increase the levels from indoor sources. So that would need to be tied together with a way of dealing with the indoor sources as you were doing that. Maybe range hoods or something like that.
Yeah, for sure. You don't want to tighten a home and not take care of the indoor sources. I will bring up a point, and it's one of these slides I wish I had made, which is I would have loved to show the plot, just a simulation of what your concentration profile looks like indoors when you have a big source of particles, and the difference between ventilating your house at, let's say, 0.5 air changes per hour and 0.3 air changes per hour. Okay. Yes, you're going to cut down on your exposure to those big indoor sources, but you're still going to have very large exposures, certainly in the acute sense. Okay, so the real point is when you're doing things indoors that emit a lot of particles, you need to ventilate a lot, not just a little bit. And then at other times, you can cut down your ventilation to keep your outdoor particles out. So I think that's really the comprehensive solution, is through a combination of source control and judicious ventilation. Okay, now the problem, consistent with what I said earlier, is how do you communicate that or bring that down to a simple enough thing of, here's a list of 10 things if you do in your house that you should either turn on an exhaust fan or open a window. I think that would be helpful, and that information may already exist somewhere, and I'm just not aware of it. But I would like to see it.
Okay, we'll take one more question in the room. So I think, okay, so here are two questions, and then we have online questions. So I want to make sure we get some of those also.
One online question, it may be that I've had a couple people ask, are any of the presentations going to be available?
All of the presentations will be posted to the web approximately 1 to 2 weeks after the workshop ends. We'll also have video of the presentations available on the web. We encourage people to contact us at indoor-pm@nas.edu if they have any questions or problems in accessing those materials, but please do give us a week or two to be able to get them up.
I had a question for Bill Fisk. With respect to portable air cleaners and allergy and asthma reduction in their symptoms, have you looked at also a combination of the air cleaner with other types of intervention, bed covers, HEPA vacuuming, washing, etc.?
Yeah, if you look at the asthma sort of mitigation literature, it is the sort of the broad combination approaches that seem to be more effective in improving health than single approaches. So there is some indication that's true, but then you don't really know what within that portfolio of measures is bringing the benefits. I will say that there were a subset of studies that used filtration systems to ventilate the breathing zone of people who are typically asthmatic when they're sleeping only, and those seem to show more consistent benefit. So that might be an approach to, some of the studies were manufacturer supported and so forth, but I think that area needs a little more look in the future.
Okay, Brent.
I just have a very quick comment. Brent Stevens from Illinois Institute of Technology. Brett, I was going to ask you about range hoods, but that would go on too long, so I'll ask you offline because I have some questions. I just wanted to make a quick comment based on your last comment about risk communication. So, early on today we showed emissions from desktop 3D printers, right? This melted plastic, and we quantify emissions, right? It's not good, likely not good. Now, when we published those, we said, okay, they emit 10 to 11, 10 to 12 particles per minute. That puts them on par on one side with cigarettes. Oh, that's bad. The anecdotal reaction I got from that, that's terrible. We've got to do something about this. That's also on par with cooking on a natural gas stove. So the anecdotal reaction that I got from that, from the general public and other people that were disinterested, said, "Oh, well then who cares about that? I'm fine. I cook all the time. I'm safe. No big deal." So there, just maybe as a moving into the discussion this afternoon and into tomorrow, there is a real risk communication issue with many of these things. So I appreciate you pointing that out.
Okay, so we'll go now to at least a couple of online questions. I specifically want to salute the person from Finland who submitted a question, and it's almost midnight, so I think he deserves an answer.
This is a question from Nusrat Jung. He writes, what is your opinion on the quality of indoor air in nearly or net zero energy homes? This is an important topic since occupant exposures to pollutants in tight building envelopes could be even higher than usual homes.
Bill's volunteering me to answer this question. I'll give what might sound like a trite answer, but I think it's actually the real answer, which is they're not that different. And this is why they're not that different. Yes, there's the possibility of higher exposure to chemicals that are released indoors, but the same features apply, which is that if you have indoor sources, you need to ventilate them. There is one, I think, systematic difference that I'll point out is that a lot of I don't want to call out Passive House in a negative way because they do a lot of good things for the building industry, but in this effort to make these very, very airtight shells, they want to not they want to limit the number of penetrations. So the common setup for these houses is to have an ERV or HRV, heat recovery ventilator that has a pickup in the kitchen, but it's a very low rate. It's maybe 20, 30, 40 CFM. And they don't have a kitchen exhaust, so they have a recirculating grease catcher above their cooking device, okay? And they have electric stoves, so they think, well, I don't have gas, I'm fine, I don't have combustion, right? But the electric stoves produce ultrafine particles, the cooking, so there is that tendency in a lot of these ultra energy efficient homes to forego the kitchen range hood, the exhaust range hood, and I think that's a big mistake. Otherwise, they have the same responsibility. The one advantage they have, a lot of them have really good, if they have forced air, a lot of them don't, but if they do, they usually have very efficient systems, so they could actually put filtration in their system and run it very efficiently and effectively.
And since my wife works there, I'll put in a quick word for National Institute of Standards and Technology. Andy Persley and colleagues have published on this topic and are doing some very interesting work there. Next question is from Richard Shaughnessy. He writes, Sergey brought up ion generators as an option to reduce bioaerosols. Given the poor performance historically as to their ability to effectively reduce particulates indoors and the across-the-board concern of ozone generation, it would seem prudent not to advise the use of these even in smaller confined areas, especially since ozone generation may be of greater concern under these circumstances. Wouldn't you agree?
Let me answer. First, I mentioned that the ozone is a very important part, and we cannot deploy any air purifiers, including ion generators, if they emit ozone. That's number one. Number two, among ion generators that I happen to investigate, there are some which are equipped with the so-called ozone guard that does not, I mean, one of them does not emit any ozone as we could measure. And again, this would be of my consideration if I were purchasing the one. And third, regarding their efficiency, they are of limited efficiency. They may probably not likely produce a CADR in excess of 100, although good freestanding filter-based purifiers can do 250 and 300. And from that perspective, if the efficiency is of concern, I would simply use the filter-based air purifiers. If the noise and other issues that I described are of concern, then alternatives could be considered. I could be, in fact, in terms of freestanding air purifiers, I'm not quite sure about the actual CADR. I may be mistaken, but one thing I can say that the CADR for ionic purifiers are much lower than a filter-based.
We can take one more question from the room. I think there was a hand up here on the right. Yeah, you. We Bill. Yes.
So, at the risk of getting a similar question tomorrow when I get my chance to speak, let me ask you a very difficult question. So, Brett, I'm looking at you, first of all. So, presuming that I am the head of a low SES household, I'm renting, I have a couple of kids, convince me, well, back up. So, this is the situation. I don't have a lot of money, but I'm going to get a tax return. And my tax return is going to be about $250. Can you convince me why I should use that $250 to reduce PM in my household as opposed to paying off my credit card or something else? And what should I spend that $250 on? And you can't say it depends.
No, I'm not going to say it depends. I'm going to say that I'm not even going to try to tell you what to spend your $250 on. I'm going to try to, if I have a few minutes and you have a question, I'm going to try to give you quick information that I can about that particular health risk. But there may be much more beneficial ways for you to spend that $250 to buy health for your family, okay, including if you're really stressed about your credit card and paying $250 down on your credit card, it's going to greatly reduce your stress level and help you sleep at night. I'd tell you to do that.
Okay, so this concludes the session on mitigation. So thank you, Brett, Bill, and Sergey. And I will.